Hey guys, today we're going to talk about jet streams and how they affect the climate of the world. So go to page 14 of your reference table and find this diagram. You'll notice that the winds that are labeled, these arrows are winds, right? And they're also labeled. For instance, these are northeast winds, these are southwest winds, these are northeast winds, these are southeast winds, and so on. And remember, as always, winds are named after where they're coming from. So these winds are named northeast winds because they're coming from the northeast. These are southeast winds because they're coming from the southeast. Remember that, okay? And remember, never eat soggy waffles should help you figure out where your compass directions are. So, remember the U.S. is in 40-degree north latitude, or around 40-degree north latitude, somewhere over here. And in the U.S., all of our major winds or our prevailing winds move towards the northeast. That's why our storms move that way too, generally. Now, they're not called northeast winds because they're coming from the southwest and going towards the northeast. They're actually called southwest winds because winds are named after the direction they're coming from. Here's another. So, yes, we call them southwest winds, northeast winds, but our traditional names for these are actually trade winds, westerlies, and easterlies. Okay, so the winds that are close to the equator, winds blowing from 30-degree north towards the 0-degree latitude, towards the equator, these are actually called trade winds. Winds that are blowing from the west, between 30-degree and 60-degree latitude. So over here and over here, notice that these winds are coming from the west side, right? Same thing over here. Sorry, right here, the winds are coming from the west side. So winds between 30-degree and 60-degree north are called westerlies because those winds are coming from the western direction. And finally, winds more closer to the poles between 60 and 90 degrees latitude are called easterlies because there's those winds that are coming from the eastern side. So 60 to 90-degree north are north and south are easterlies. 30 to 60-degree north and south are westerlies, and in the middle between 0 and 30-degree north and south are trade winds. So, jet streams, what are they? We've talked about jet streams before. Jet streams are very fast moving air currents that circulate above the earth, and jet streams form when colder and warmer air meet, right? And when they meet, they form these really fast winds going from west to east. And they're really so as fast as 180 to 275 miles per hour. So, remember, jet streams blow from west to east. So there are two types of jet streams, and they're labeled in your reference table as well. We have the polar front jet stream and the subtropical jet stream. Okay, so the polar jet streams are found closer to the poles. These X's are showing the polar jet streams, and they form when the cold air from the poles meet the warm air from the mid latitude. So um, near the equator is really, really warm air, right? The farther away from the equator we're going, our air is actually getting a little cooler. So around here in the mid latitudes, our air is not as hot as the equator, but still pretty warm. And then if we go near to the poles, our air is really cold. So that's why we're creating two different jet streams. One is the polar jet stream right here in the northern hemisphere and here in the southern hemisphere, where the cold air from the north and south pole are meeting these warm air, but not too warm air in the mid latitudes, that are somewhere between the equator and the poles. Okay, so that's what we call a polar jet. Notice polar jets move from west to east. Now, another type of jet stream we form are subtropical jets, subtropical jet streams, and this is when the warmer air from the mid latitudes, the yellow areas, meet the really warm air, almost hot air from the equator. Okay, so since there's different temperature differences there, we're creating another type of jet stream still moving from west to east. Okay, and we can find this in the northern and southern hemisphere, and it's also labeled here for you. Another thing you should notice, and don't mind the Hadley cell right here. We're not going to talk about this just yet, but notice that the subtropical jet streams near the equator are actually higher in elevation than the polar front jet streams near the poles. Why? Because think about it. Near the equator is our warmest air, right? And the warmer the air is, the higher it will rise because warm air is less dense. So that's why our subtropical jet streams, you can see, are much higher in altitude compared to the polar front jet stream. and it's kind of like this. So we're creating these convection currents, and in between the convection currents, where the different air temperatures are meeting, we're creating these jet streams, really fast winds blowing from west to east. So pause this video, try number 7. The diagram below shows the locations of two major jet streams in Earth's atmosphere. We have the polar front jet stream and the subtropical jet stream. And it's also showing us the latitude where they're located. Compared to the subtropical jet stream, the polar front jet stream is at A. The correct answer is C. Compared to the subtropical jet stream, the polar front jet stream is actually at a higher latitude. Remember, the equator is at 0 degree latitude, right? The closer towards the poles we get, the higher our latitude is. Our numbers are increasing, right? So it goes from 0 to 30 to 60 to 90, and even here, 0, 30, 60, 90. So when we're talking about higher latitudes, we're talking about closer to the poles. So that's why, compared to the subtropical jet stream, our polar front jet stream is actually at a higher latitude, around like um, 60-degree north and south, but it's a lower altitude, meaning it's not as high up in the sky, right? And you can see it here. The polar front jet stream is a little lower right here in altitude than our subtropical jet streams, which are a little higher in the sky. Try number 8, pause this video. Jet stream winds over the United States generally move where? The correct answer is B, west to east. Jet streams are always moving from west to east, okay? And this is because of the direction the earth rotates, and we'll talk about that in the future. In the next video, we'll talk about climate factors.